All right. No, darn it, wrong thing. There we go. Okay, here it comes. All right. So let me go through this with you. So for the first one, right? We want to know if these equations define y as a function of x. Okay. Now, hopefully you can see that if you're looking at x times y equals -1, I mean, what I did was I just graphed it. So this is what the graph looks like. It's very similar to x times y equals 1. But hopefully you can see by looking at this graph that this does in fact pass, what do you call it, the vertical line test. It does pass the vertical line test. I mean, hopefully you can see that. You know, you can imagine drawing these vertical lines. Okay. I mean, on a test, it probably would be a good idea to draw some vertical lines. But again, hopefully you can see that it does pass the vertical line test. I wonder if there's a... Nah, forget it. I was going to try and draw some vertical lines, but let me not mess with that. But it does define y as a function of x. And in fact, we can get y in terms of x. That is, we can get a formula for y in terms of x. Namely, we have x times y is -1, right? So what can we do is, well, we can divide both sides by x. That's what I'm doing here. And we end up with y equal to -1 over x. That's what we get. Keep in mind also that x cannot be 0, and neither can y. That should be kind of obvious from the beginning because you have x times y has to be -1. So there's no way x or y could be 0. So dividing by x is okay. All right. Okay, are there any questions on that? Okay, well, for the next one here, you could probably tell that this fails the vertical line test. You know what? Let me just draw a line. If we were to draw a perfectly vertical line, right? Hopefully you can see that this line here, let me make it thicker. See if I can make it a little bit thicker. Oh, wait, there it is. No. That. See if I can make it even thicker than that. There we go. But hopefully you can see that. Wait, let me make it. No, that's fine. You can see that the vertical line I drew, right? That intersects the graph more than once. I mean, you can see that. At least I hope you can, right? So because of that, this does not define y as a function of x. So this equation does not give y as a function of x. So because of that, so that's what we get here. So we don't have y equals f of something. For the third one, actually, you know what? Let me get this. Okay. I mean, from the first one, you should be able to see, no, not the first one, what am I saying? The third one. Here we go. I mean, I guess this one you really didn't have to draw a graph because you should be able to tell from this equation that the graph of this is just a non-vertical line. And we know that it defines y as a function of x. I mean, if you did draw some vertical lines, though, let me draw a few, right? This only intersects at once. Oh, come on. What the heck? Why is it not letting me? Fine, we'll play hardball. There we go. Right, here's another one. You know, if you can imagine drawing a bunch of these vertical lines. See? And you could see that, yeah, they're only intersecting the graph once. Okay? I mean, any non-vertical line we saw defines y as a function of x. Okay, that's good. So here, let's get y in terms of x. And that's what I'm doing here, right? I get y all alone. So I subtract 3 times x. from both sides, as you can tell, and we get negative 5y equals 15 minus 3x. But remember, we don't want minus 5y, we want y, so we divide both sides by minus 5. Doing so, we get y equals minus 3, minus 15 over minus 5, minus 3x over minus 5, which is this. So we get y equals negative 3 plus 3x over 5. That's what we get. Now, let me just go back to the first graph. I really want to do this. I mean, hopefully you can tell by just looking at these vertical lines, segments, I guess maybe is better. But hopefully you can tell that the graph passes the vertical line test. What the? Okay. Oh, jeez. Just make another one then. What's doing that? Right? I mean, as you get closer to the y-axis, it looks like it fails the vertical line test. But as I said, for y equals 1 over x, it does pass the vertical line test. So I just felt like drawing a few, so just to illustrate it. Okay. Yeah.
For number 2, when you have x equals the absolute value of y, how did you solve that? Like, what do you do from there?
Once you know it's not a function, y is not a function of x, you just say, well, it's not a function of x. In the directions, I hope I said, if y is a function of x, get y in terms of x. But in number 2, we didn't have that, so we just say it's not a function. It fails the vertical line test.
So you just graphed it as the absolute value of y?
Right, and then I drew a vertical line that intersects the graph more than once, and because of that, there's nothing else you really can do.
So what did you put in for y equals on the graphing calculator?
You would
like, how did you write
that? I drew it through Desmos. You can actually type this in Desmos and it will draw it.
Okay.
I mean, I don't know how to graph it in a graphing calculator off the top of my head, but with Desmos you can graph it though. I just typed this equation in, and I was able to graph it, and it graphed it for me.
Okay. Thank you.
You sure? I mean, are you sure? Or
Yeah.
does it? Okay. Just want to make sure I answered your question. So hope that came out right what I said. All right. Any other questions or? Okay, so I guess we'll stop here because we're out of time. So